Pradeep?
Hello, hello, hello.
Good morning to all. Myself, Dr. Amit Shaw, sir, Dean Student Welfare, LNCT Group, Bhopal. Before going to start the workshop, I would like to welcome Dr. Anupam Choksey, sir, Executive Secretary, LNCT Group, Dr. Ashok Kumar Rai, sir, Director, Administration, LNCT Group, OSDs, principals, HODs, faculty of LNCT Group, and all the participants. As we know, we have an hands-on workshop on image processing and face detection. So I would like to welcome and invite Mr. Prateek Mishra, Director TechSim, to start the workshop. Hello, am I audible?
Yes, sir.
Good morning to all. Myself, Dr. Amit Shaw, Dean Student Welfare, LNCT Group. Before going to start the workshop, I would like to welcome Dr. Anupam Choksey, sir, Executive Secretary, LNCT Group, Dr. Ashok Kumar Rai, sir, Director, Administration, LNCT Group, OSDs, Principal, HODs, faculties of LNCT Group, and all the participants. As we know, we have a hands-on workshop on image processing and face detection. So I would like to welcome and invite Mr. Prateek Mishra, Director TechSim, to start the workshop.
Okay. Thank you so much, sir. And first of all, I would like to thank to all of you who joined this workshop and this online live webinar, right, on hands-on workshop on image processing and face detection, right? So today we are going to cover really interesting topics, right? Not just about Python and not just about libraries, right? We will cover about images, how we can process our images, how we can detect our face. Like as you can see in my laptop, right? My laptop camera is detecting my face because I already trained my machine with my face, right? So my machine says that hi Pratik, right? So it's detecting my face, right? And after that, it's just give me the answer that who are like in front of this camera, right? And we are using this technology in our day-to-day life, right? Not just applications and not just a coding part, right? In our mobile phone, we are using it when we apply uh, face unlock system, right? Or face unlock system, face detection system. When we open our camera will also detect multiple faces. When you want to like capture the image or just selfie you want to try to take, right? Then what happened? Whenever you will try to like click the image or capture the image, right, there will be boxes on your faces, right, or multiple faces, not just only one face. On multiple face we can make box, right, or my mobile camera will make the box, right. So how it's possible and how my machine is going to work and my machine is going to detect the faces, we will learn about it today, right? So it's really interesting class. You will enjoy, definitely you will enjoy, right? Because everything will be hands-on. There's nothing like PPTs and just theory part, right? Everything will be hands-on practicals. I will start just point of coding, right? We will start with coding and make our project, right? So two concepts we are going to cover today, right? One concept is about face detection. Second concept is we are going to cover object detection. Like if we have multiple objects in our images, then how we can detect, right? So let's start, right? Because I think all of you are waiting for this, that how we can make this project, right? So I will directly jump on coding part, right? And step by step, I'll explain you that how we can make this code and how we can work on it, right? I think that I don't have to take too much of time to explain what is image processing and all, right? Because we all know about it, that what is image processing, why it's important, right? It's a part of AI and all, right? So a lot of discussions and lot of stuffs available on websites, on YouTube and other, on all places, right? But what we have to discuss about the project, how we can make it, right? About image processing, you know, you can just visit the websites, blogs and all the places. You will got a lot of stuff available in the internet, right? But how we can make this, how we can implement it right from scratch, we will learn today, right? So that's the concept to conduct this workshop by LNCT group, right? And by me, right? So just enjoy this workshop and learn a lot of things. There will be a online chat option for all of you, right? So I want to announce just one thing. During the workshop, definitely you will face a lot of errors or you will face a lot of doubts, right? So what we will do, like each step, right? I will ask you for the question and give you 2 or 5 minutes, right, to ask your question. So it will easy to handle your queries, right? Handle your questions, right? And you will get your answers also, right? So I want just this thing from all of you, right? So don't ask your questions during my explanation time, right? Because on the particular time I will not able to just solve your queries or just visit your queries, that what doubt you have, right? Okay, so I will give you the time, then you can ask me that whatever you have, then we will solve it, like uh, definitely, right? Okay, so just enjoy, right? And let's start, right? Because uh, just I'm going to minimize this, right? It's just continuously working, right? And I'm going to jump on our PyCharm software, right? We are going to use PyCharm, right? This is really important software we have, right? And with the help of this software, we will code our project, right? We will like code our project and all, right? Okay. So here we have this folder. In this folder, I have some images. I have some images or some required files I already created, and I already just created these files, right? So I will not able to copy and just it will not take too much of time, right? What I will do, I will just start coding. I will just create a new file, new Python file, which is possible to create at this step, at this point, right? And just start playing with images, right? Okay. So just I'm going to just right click on new Python file. I'm going to create Python file, right? Okay. Image face, right? Simple image and face. We are going to play with this images and face both, right? So I'm going to create this file, new file, right? Okay. This folder and all the codes will shared by you, so shared with you, right? There is no issue, right? Don't worry that you don't have this file detect image.jpg and Thorny's image docker and her cascade files and all these things. Don't worry about it, right? All the files, all the codings will share with you, right? So you can access it and you can make your own project. So don't worry about it, right? Okay. So I think we should start, right? Okay. So just before starting, if you have any question, if you have any query, right, and if you any questions suit, so just you can ask me, then we will start our question. If you done anything before this class in this particular field, and if you have any question, you can ask me. Okay, so I think there is no doubt, right? So I'm going to start our coding part, right? And just play with this, right? Okay. So we all know that how my Python work, right? And I hope that all of you have basic idea about the Python, right? But still, I'm going to cover some basic concept about the Python, that how it work and how all the things, right? So I'm going to open my Python IDE. Python IDE is simplest part, right? And easiest terminal and all the things we have. So with the help of this, we can code our Python or Python syntax, right? Okay. So basic Python, you all know, right? There is no doubt, right? I'm going to jump directly importing the libraries, how we can import libraries and how we can play with them, right? Okay. So now we have this page, right? So as we all know, if we want to add any number, we will just write the code 5 plus 5, we will get the answer. So it's not a big deal, right? It's simple, right? If you want to store any data in any variable, right, then just x equals to x is my variable, right? So variable name or just x equals to any number, any character, whatever you want, you can store. It's simple, right? If we have something in different variable, right, when we will use it or we will save it, right? If I want to add these two numbers, so x plus y, so just it will be add, right? Okay. Now after that, what I want import library, like import math. Import math. Math is the library. We all know, right? We have this library, right? And we can play with this library and perform mathematical operations, right? Similarly, we have different library, NumPy, right? Import NumPy. We have these two different libraries, and these two different libraries can perform multiple tasks, right? And they have a different capabilities to perform your task, right? Okay, so I'm going to use NumPy right now. I'm not going to use math. So as NP, as is stand for short name, or you can say nickname. NumPy is my original name. I'm going to decide nickname for this library, right? So NumPy as NP. So now if we want to access, if we want to call the functions like from this library, right, then we will use np, like np dot array. We are going to create just one array, right? And we all know array contains same type of data. Right? So I'm going to just store some numbers, right? It's done. We created this array, right? If we want to store this array somewhere, like suppose this array is my image. This array is my image. So now it's done. I have a one array in a variable image, right? Now, if I ask you that what is the shape? Shape means how many rows and how many columns we have, right? So how we can check img dot shape? Simple. Img dot shape. If I execute, I will get 6 comma. 6 comma means we have only 6 value in this array. We have only 6 value in this array, right? There is no column, there is no row. The 6 value we have. Now that's called one-dimensional array, right? Or one-dimensional data we have, right? Multi-dimensional data will be multi-dimensional. Like we can create a two-dimensional data, right? So I'm going to create two-dimensional data. How we can create and how we can play with this, right? Let's see. So x equals to, this will be your parent list. This will be your parent list, right? After that, I'm going to open and close. I'm going to store some numbers. Some numbers I have. After that, in again child list, I'm going to store some numbers, right? I'm going to close this parent list, right? It's done. Open array. You can see array, right? Okay. Now I want to convert this data in array. So how we can convert? Img equals to np dot array. np dot array of x. Pass this. So this x data will convert your numpy array. This x data will convert in your numpy array, right? Okay. So now, sorry, it's generating the error. Okay, there's a 3R, right? That's just because of one mistake or one error, right? Okay, img. We have this array. If I ask you about the shape, so img dot shape, you will get the answer 2 comma 3. It means how many rows we have? 3 rows we have. How many columns we have? Sorry, how many rows we have? 2 rows we have. And how many columns we have? 3 columns we have in this data or in this variable, right? So this is your array. You can create it. Now, if I give you the task that I want only first value, I want only first value 323, or I want only first two values 323 and 34. So how we can extract it? It's simple. It's really easiest task we have, right? Okay, I'm going to just yes. Okay, so now img of 0. If I ask you about the 0, then you will get 0, a complete array. You are getting a one-dimensional array, 0, because on 0 index number we have one-dimensional array, right? If I say that I want 3 to 3 only, 3 to 3 only, right? So this will be like img of 0 of 0. Or if I give you the condition that you have to filter 34, so it will be 3 4 or 0 of 1. Execute it. 34. We have this, right? So we can filter our data. We can extract the values from complete NumPy array, right? But suppose if I give you the condition that I want these 4 values, 332, 34, 32, and 3. I want these 4 values, right? How we can extract it? How we can filter this data? It's simple, very easy we have, right? Just we can use this image of how many rows I want. First row and second row. How many rows I want? First row and second row. So there is a term called slicing. Slicing. How many rows I want? I want index number of 0. So 0th row, comma, first row, right? So if comma is not going to work here we will work on column. So 0 to 1. So we have to increase just plus 1. Why plus 1? Because one step or just one extra point will be your stopping point, right? So 0 colon 1, here you want data for 0 row and 1 row, but you want to stop on second row. We don't have the second row, but it will not generate any error. So what we will do, 0 colon 2. Bring my rows. How many rows I want? 0 colon 2 rows. How many columns we want? How many columns we want? So again, 0 colon 2, right? So comma, then column number, 0 colon 2. You can see this, 0 colon 2. So we have this data. We can slice our data, right? It's simple possibility we have, right? And it's really interesting concept, right? So that is just basic of NumPy, right? Remaining part we are going to cover on PyCharm, right? Because I want to just introduce about the slicing and nothing else, right? The remaining part we will start or we will cover from PyCharm, right? Okay, so just let's play with this. So here I have, right? I'm going to use one library we are going to use for this complete learning journey, right? We are going to use a library name is OpenCV library, right? How we can install this libraries, right? So when you installed your PyCharm, when you installed your Python, right, you will get possibility or you will get ability to access your pip command, right? Pip, Python installing or Python package installing command, right? Or package installing pipeline is called package PIP, package installing pipeline command we have, right? Pip, you will get this command, right? So how we can install this? Just do nothing, just open your CMD, like as in my window I'm going to open terminal, right? In my laptop, right? I'm going to open a new terminal because it's already working. As I have this terminal, right? I have this terminal already created. So in this terminal, what we will do, we'll do just nothing. I'm going to open it. Terminal called just your command prompt, right? CMD. Just type your pip install your library name, right? So my library name is OpenCV dash contrib, right? OpenCV dash contrib dash Python equals to what version we are going to use. Actually, latest version we have 4.x version we have, right? But it's still in beta version or testing version, right? So we are going to use 3.x version. So 3.4.4.19 version we are going to use. When you run this command, what this command will do, this command will download your OpenCV from browser, from internet world, and install in your system, in your local machine. If I execute this, pip is not executing because I'm not using Python, right? In Mac or in Linux, we can run multiple Pythons, right? So I'm using Python and Python 3 both, right? Python is stand for 2.x version, Python 3 stand for 3.x version, right? So I'm going to use pip3 install. If I execute this line, what happened? It will download your library from internet world and install it. And as you can see, requirement already satisfied. It means I already installed this library in my system, in my machine. So that's why it's not going to download again. Otherwise, it will download in your system, it will install in your system, right? And you can access it freely, right? Okay. I'm going to clear this command, it's done, right? Okay, now let's play with this. So how we can open or how we can use OpenCV library? Point is this, how we can open this OpenCV library, right? Simple. import as if we want to use numpy, then what we will use import numpy as np. Simple, as we all know, import numpy as np. But what about cv, a computer vision library, OpenCV library? Actually, OpenCV library have already have a nickname. We don't have to define as np or as other name, right? What we will use just import cv2. Simple, import cv2. Use this and play with this. So we have this library, we imported this library, import cv2. What next? If I want to open any image, or if I want to show any image, then how it's possible? How we can show any image or how we can open any image, right? So we will follow, or we will use just one or two steps of coding. You will get your image open, right? As I'm going to open this image. We all know this person, right? We all know this person, right? So I'm going to open this image with the help of my coding. How we can open this image? Let's see. Okay, so now what I'm doing here, if I want to open any image, so I'm just using IMA image equals to how we can open cv2 is a library. Inside the cv2 we will call function im. After that, what you want? So read or write or decode or input. Multiple possibilities we have. I want to read. Firstly, we will read our image, right? So how we can read cv2.imread. In this imread, we will pass the path of my file where we stored our image, right? So my image is in same directory. I'm working with this Python file, and my image is this dhoni.jpg, right? So I'm just going to copy this name and pasting here. When I paste here, my image will be there. Now let's see, print your image. What output you will get? Let's see. Print your image, right? So what we have in this variable, we are going to print, right? Okay, so let's see and let's play with this. If I want to run, what I will do, just right click and run my file name, image face. If I execute this, after some time, you will get this data. Here you can see, here we are getting numbers. Can you see this? Here we are getting numbers, right? And this number says one-dimensional, two-dimensional, and three-dimensional data. Here the number says that one-dimensional data we have, two-dimensional data we have, three-dimensional data we have. It means this array is not one-dimensional array, not two-dimensional array. The complete image is three-dimensional array, right? But how we decided and how we know that this image is three-dimensional array and how many data we have in this array, right? And what are these numbers? 127, 94, and 49. If we got the point about these numbers, we can play with our images, right? Because that's complete learning or complete implementation of images and all is just these numbers, right? If you know about these numbers, then how they exist and how they play the role to create your complete image, right? We can learn, or we can implement any concept on our images, right? So I'm going to explain that how it works, right? And why it's really important concept we have, right? Okay. So now let's start what we are going to do. If I open this image, as you can see here, we have this image, right? So this image has some size. We all know, right? We have some rows, we have some columns. Or you can say we have height and width. So height says number of rows, how many rows we have, and width says number of columns, how many columns we have, right? Height and width, right? Okay. So if we want to play with this, right? So every image is a combination of pixels. Like I'm going to draw this. I'm going to just explain you about the image, right? It's really interesting concept. I have this image. I'm going to draw this. I have this image, and this image divided some size. We have these number of rows or number of columns, you can say right now, right? I'm going to draw this. These columns we have, and these rows we have. Right? Okay. If I ask you the shape about this image, right? Then how many rows and how many columns we have in this image, right? So if I start counting here, So first column we have, second column we have, third column, fourth, fifth, sixth, seventh, eighth, right? How many columns we have? 8 column we have. How many rows we have? 1 column, 2, 3, 4, 5, 6. How many rows we have? 6 rows we have, right? So if I ask you the shape, that how many rows and how many columns we have in this image, right? You can say me 6, 8. How many rows we have? 6 rows we have in this image. And how many columns we have? 8 columns we have. Do you know, we whenever we will open any image have some size, 720 cross 10080, right? Something, right? Any number of pixels it can exist, right? It can be, right? So this is your size. How many pixels you have in just one row? How many pixels you have in one row, and how many pixels you have in one column, right? That's all about images, right? So that's why we have two-dimensional data. How many rows we have? How many rows we have? 6. How many columns we have? 8 columns we have. 8 columns we have. And each pixel consists three numbers, right? Because RGB, red, green, and blue. We have this concept, red, green, and blue, right? Because all colors in this world just made by just a combination of three colors, right? RGB, red, green, and blue, right? So this pixel is a combination of these three colors. As you, if you notice here, we have three numbers. So this value 127 is R, 94 is G, and 49 is B, RGB, right? So this is all about your color concept. So just this is your one pixel complete. This is your second pixel. This is your third pixel, and same thing others. Same with others, right? So now, if we want this value, this pixel value, right? So index number will start from 0, 1, 2, 3, 4, and 5, right? Same thing. It will start from 0, it will start for 1, it will start for 2, same thing with 3, 4, 5, and 6, and 7. If I ask you the question that what is the location of this pixel? What is the location of this pixel? As I'm going to color it, red color, I'm going to fill in this pixel, right? So what is the location of this pixel? So firstly, we will find the number of rows, right? In which row it exists. So this row is 0, 1, and 2. Second row, it exists in second row. So number is 2. After that, column is 0. Column is 0 we have. Column is 0 we have, right? So this is your pixel. This is your pixel. If I ask you this image pixel, this image pixel color, as I'm going to color it, right? I want the location of this pixel. How you can give me the answer that location of this pixel, right? So firstly, we will find the rows. So this row is 0, 1, 2, 3, 4, right? Fourth row. So row number is 4 because row number is 5, index number is 4, right? So 4, how many columns we have? 0, 1, 2, 3, 4, and 5. So this will be 5. This will be your 5. And how many values you have? How many values you have in this pixel? We all know 3 values we have in this pixel. So fourth row, fifth column we have, and in each cell we have 3 values. 3 values. That's all. That's the main concept about our data or about our images, right? So complete algorithms, it can be your machine learning algorithms, it can be your deep learning algorithm, it can be normal image processing things, right? Without machine learning, without deep learning, right? All algorithms or all technologies are using this concept basically, right? About pixels, right? How many pixels we have, right? So just play with this. So I hope this concept is clear to all of you, right? And I hope there is no doubt for all of you, right? Okay. So we can print this image, but what I'm going to print about the shape. I'm going to print about the shape, right? So before printing this, I want to show you that what will be the shape of this image. What will be the shape of this image, right? So let's see what will be the shape without printing it. So I'm going to open image processing and face detection folder. This is our folder, right? In this folder, I have this image, Donnie, right? I'm going to open details about this image, right? Just get info. If I open this get info, I will get the size of this image, width and height. 1280 bits. Width is 1280 pixels we have, right? And 720 pixels we have as a row height, right? So width is 1280 and height is 720. So if we reverse it, then 720 will be my row numbers. 720 will be my row numbers. How many rows we have? It's decided by height. how many columns we have is decided by width, right? So 1280 will be the width of this width of this image, right? So 1280 will be my number of columns, how many columns we have, right? So let's play with this. Let's see. So if I execute this code, then let's see what will be the answer. 720, 1280, 3, as I think this will be the answer. Yes, sure, right? 720 rows we have, 1280 columns we have, and in each cell we have three values. That's why we are getting 3. That's all. It's really interesting concept, right? It's really interesting concept we have, and we can play with this, right? So now we know about the basic of images, how they work and how they exist. Now next step is I'm going to comment this, right? So when you will get the code, you can use it anytime, right? I want to open my image. So how we will open my image? Just open cv2.imso. cv2.imso. Inside this imso, we have to pass two arguments. Right? In first argument, first function imRead, we are passing only one argument about the image. But in imso, we have to pass two different arguments, and two different arguments are just based on, like, first argument is your title of your image or title of your window, right? So it will be title, and second argument will be my data, where I stored my image. After reading my image, where I stored it. So I stored it in image, image. cv2.imso title, image. So what this command will do, it will open your image. Whatever you read in this variable, right? What you stored in this variable, it will open, right? Okay. So let's play with this, run this code. It will just take some time, right? To close this folder, as you can see, there was a one folder pop up just for a second and closed it, just because of you not applied any delay. That how much time you want to provide, right? And how, like, what's the delay to show this image, right? So how we can apply the delay, right? Okay. So what we are doing here, we don't know that how much time I need to see this image, right? So what we will do, we will apply while loop. While true will be like infinite time. After infinite time, how we can break this loop, and how we can like close my window, right? Right? So let's see with this. So we will apply the condition if cv2 dot bait key, and what bait key will do, bait key will provide you some instruction. Bait key will just read your keyboard keys. What you are going to press, right? I'm going to just pass one is just 1 millisecond and nothing else, right? So in every millisecond, it will capture your keyboard keys, that what you are going to press from your keyboard, right? So what I'm going to press, if I press enter stand for, like, 13 stand for enter ASCII code, right? Whenever I will click enter, the ASCII code will be 13, right? 313, right? 13. So what we will do, we will break my program. Right? So it should be double equals to, not single equals to. So what we are applying here, if we press enter from my laptop, my program will break, or my loop will break. And if my loop will break, will stop. So in the image will stop, right? Okay. So let's see how it works. What I'm doing right now, I'm going to run this code, run image of face. If I execute this, it will take a little bit of time, and you will get image popped here. As you can see here, we have this image, right? And we open this image with the help of Python coding. Here you can see title. We decide this title as a window title, right? We can change it. So how we can close this image, how we can close this program, just click enter. As I clicked enter, my image is closed. And my program also baked. My program is completed. You can see here, process finished. Process finished. It means there is no error. Your program is completed successfully, right? So that's all. That's the basic thing, right? Okay. What next? If I want to, if I want to read any other image, if I want to read any other image, how we can read, right? Oh, sorry. If I want to read any other key from my laptop, then how we can read it, right? So just use ORD. ORD is a function which gives you the ASCII code of any keys, ASCII code of any keys. Like we know the inter command key, inter ASCII code is 13. We can pass it, but we don't know that what is the ASCII code of Q. Maybe we know, but we have to read it, right? We don't know that what is the ASCII code of D or what is the A, right? So what we will do, we will just pass ORD of Q. Q is stand for quit. So whenever we will press the Q, right, Q key from my laptop, my program will stop. The program will stop, right? Okay. So now it's simple, simplest thing we have, right? Okay. Next, we are going to what we are doing here. After closing the loop, right, I'm going to change first this title. So I'm going to change this my image title. So it will just give you the real overview that how it's work, right, and how it's going to change, right? Okay. There is just one question that OpenCV or CNN. Obviously, CNN, right? CNN is a deep learning algorithm, right? So OpenCV is just a basic possibilities we have in OpenCV. Apply deep learning also. With the help of OpenCV, we can apply deep learning, right? But CNN is a pure deep learning, right? So with the help of deep learning, you can play with a lot of possibilities, right? Or you can use it anywhere, right? Okay. So now CV2 dot destroy all windows. So what this command will do, this will destroy your windows. This will destroy your windows, right? So what it will destroy? It will destroy your pop-up window or whatever you will open. When you open an image, there will be a one window. Do you notice? There will be a one window which is going to open by your inso command, right? So after closing the loop, what I want to destroy, I want to destroy all the windows, right? Whatever it can be image command or it can be image window, it can be your camera's window and all these things, right? Okay. So if I run this code, it will take time and it will open your image. Yes, you can see. Here we have this. We have the same image, right? It's going to same, but it's going to open by my Python code, right? And here you can see my image title. I'm going to change the title. Title is going to change, right? So my image title we have. If I want to close it, I will not press enter. I will press Q. If I press Q, it will close like this. Program is closed, right? So there is no error. There is no like any warning that you can't run this code and all these things, right? Okay. Now, what I want next, if I want to convert, this is my image, if I want to convert the color of this image, if I want to convert the color of this image, how we can convert it, right? Okay, so let's see. If I want to change this image from color image to gray scale, it's called gray scale, right? So how we can convert it? So gray equals to what I'm doing here, gray equals to cv2 dot CVT color. CVT color is a function inside the color convert color, right? Convert color, right? So CVT is color is a function inside CV2 library, right? And I want convert my color of my image. And what color I want? So I want CV2 dot color, and color will be BGR to gray. BGR to gray, right? This is the function. Color BGR to gray, not RGB. Red, green, blue is not going to follow this pattern in OpenCV or CV2. It will be BGR, blue, green, and red to gray color, right? So my complete image from color image will convert in gray image, right? And we can use it, we can access it, right? Okay. So now what I'm doing right now, I'm going to open two different windows. So this will be my gray image. And in this image we will pass just gray. Gray variable, right? I'm going to pass gray variable, right? Okay, that's great. So we are going to open two different windows. Now let's run this code and see the magic that really my image is going to convert in grayscale or not. You will get two different images here. Let's see. Here we have one window and two windows, two different images we have. One image is my gray scale image or gray color, or just you can say black and white image, right? And second image is my color image, right? So whenever we will learn and whenever we want to train our machine with our faces, firstly we have to convert our face in gray scale. First we have to convert our face or our image or our frame in grayscale, right? So this is all about converting your image color to gray, right? So this is the just basic concept we have, right? Okay. Now, next, this is just playing with images. This is just playing with images, right? What about if we want to play with my face, play with my real face, right? Not just play with images, right? So how we can play with my face, right? Okay, so let's see. Or you can say how we can play with camera. If I want to open my camera, then how we can open it, right? Okay. So let's see. It's simple and easy. What I'm doing right now, I'm going to save this same, right? I'm going to close this in same folder and just click right click, Python file, open cam. Cam stands for camera, right? Okay. I'm going to open my camera. So how we can open my camera? Just simple. Import CV2 library first. So import CV2. After that, just one line of code, you will get your image in front of you. Just your camera will open. Just one line of code, right? So how we can open my camera? So we have to open just cam. Cam is stand for just you can say camera. So cam equals to CV2 dot video capture. Video capture. Inside this video capture, what we will pass and what we have to pass. So we will pass number. It can be 0, it can be 1, right? It can be any other number, right? It can be any file access, right? So if you are going to apply cv2.video capture, then how actually, what camera or which camera you want to use? You want to use your inbuilt laptop camera or you want to use any different camera, right? So I want to use my laptop camera, so I will pass 0. After that, do nothing, just apply while true loop, while true. This while loop we will apply. After applying the while loop, what we will do, we will read my image. We will read my image. Whatever my camera is going to capture, I will read it. So how we can read it? Firstly is RET and second is IMG or IMAGE, image, and cam dot read. Cam dot read. After executing this RET comma image equals to cam dot read, what happened actually exactly? When you read this data from this camera, there will be two things. First will be just true. In RET you will get true. It means your camera is working properly. There is no error, and your camera can capture your images, right, and capture your frames from the camera, right, and images or your frame will store in image variable here. Here we will store image, right, or like frames, whatever my camera will capture, right. After that, do nothing. Just open your file as it is. Image face. I'm going to open this file, same, right, and I'm going to copy and paste. Simple. Just do this. I'm going to copy. I will not just paste while, right, and after that, here, like you can see, so I have this image. I'm going to convert this image in grayscale also. So my image, my face will be a color image, color face, and gray face both. And you can see my color face. And here you can see my gray face, right? So here we will pass my color face, here we will pass my gray face, right? Simple, like it's easiest possibility we have. So I'm going to run this code. So if I want to run, I will use my terminal. Right? So Python 3, my file name is opencam. Opencam.py. It's going to open my camera. And as you can see, two different cameras we have, right? My machine is going to open my camera and two different cameras I can see here, right? One camera is my color camera. It's just going to generate my color image as my camera is going to record, or camera is going to read, right? And second camera is just generating a grayscale image, right? So this is all about our images, how we can access our camera. Just one line of coding, we can access our camera and we can play with this, right? So it's really interesting concept we have. And in next step, what we are going to learn, how we can make box stand for how we can detect our face in this image or in this camera as a live camera, right? My camera is detecting my face live, right? It's not detecting, it's just capturing, right? But how we can detect my face in this image, or how my machine can detect my face in this image, right? So let's play with this, right? So I'm going to close Q. If I close Q, my window is closed, my all cameras or all possibilities is closed, right? Okay. Okay, so just let's play with this, right? And this is your just camera, right? What next we are going to implement? We are going to learn that how we can detect my face. This is my image. This is my image. This is my gray image. Next step is how we can detect my face. That's all. We have to find this one thing, right? But before detecting my image, what I want to draw just one rectangle. I want to draw just one rectangle on my image, on my face, on not on my face, on my image, right? I don't know where's my face in this complete image, right? But I want to just draw or just make a one rectangle, right? So how we can make the rectangle? It's easy possibility we have, easiest possibility, right? Okay, so let's see this, how we can make it. So after converting the gray, right? What I'm doing, I'm going to make a just one rectangle. So how we can make it? CV2 dot rectangle, CV2 dot rectangle, and in which image I want to make rectangle, on gray scale or on color scale or color image, right? So I want to make rectangle on color image, right? So I will use just image. Inside this, you have to pass only four arguments. First is your image, right? Second is actually what's the mean of starting coordinate. Try to understand this concept. I'm going to open Dhwani sir photos, right? Here I have Dhwani sir, right? What I want make a rectangle here. And how we can make the rectangle? Try to understand this. Here I will make rectangle like this, because this is my face. I will make just one rectangle like this. Here I will make the rectangle, right? But how we will know that at which point, what is my starting point of this rectangle and what is the ending point of this rectangle, right? So this coordinate, this starting point, right? It's called x comma y. X coordinate I want to find, y coordinate I want to find. And if we have idea about the width, what is the width of this rectangle, right? If we have idea about the width, right? And if we have idea about the height, two things. If we know these two things only, so this is my height. This is my height. Right? Okay. And this is my width. Right? So if we have these two values more, x comma y, a first coordinate only we need, and w, we need just width, right? What is the width of your rectangle? And we need height. What is the height of your rectangle? Right? So what we will do after this, we will just find the coordinates of this. How we can find? We have x and we have y. We are not going to change in x, we are going to change in y. So x coordinate will be same, y coordinate will be y plus h of this coordinate, right? X will be same, y will change. For this coordinate, y will not change, x will change. So x plus w comma y coordinate will be same, x coordinate will change. For this coordinate or for this point, what will change? Both values will change. So x plus w, x coordinate is going to change, and y plus h, because y coordinate is again going to change, right? So we have all four coordinates. It means we have only x comma y comma w comma h. If we have these four values, we can find these four coordinates directly, right? Okay, that's all. And the simple concept we have, right? Okay, so just clear this drawing. I'm going to just clear this drawing. After that, I'm going to close this photo, right, or this image, right, rectangle. So we have to pass starting x comma y here, x comma y here. So suppose if I'm going to define x comma y comma w comma h, four variables I'm going to take, and in this four variable I'm going to define my x coordinate and y coordinate, right? So in x coordinate I'm going to define like 200 from x and 300 from y, or you can say 300 from x, 200 from y, rectangle or square, whatever you want, right? So w will be 250 or 240, no issue, right? And h will be 240. H will be 240. These four values we have. These four values we have. Now, if we want to draw the rectangle, how we can draw? Just pass x comma y coordinate first, comma. In second variable, what we will pass? We will pass my width and height, right? So just x plus w. This is my width, and by plus h. By plus h. This is my height. Width and height. We have to pass just two things: x plus w and y plus h. This is the two values, right? We are going to pass. That's all, right? Next step, we will pass the color, right? Color of my rectangle, right? Rectangle color, right? So BGR, blue, green, and red, right? If I want to make the red color, if I want to make the red rectangle, then what we will use 0, 0, 255. 255 will be a red rectangle. It will make a red rectangle, right? After that, thickness of your rectangle border thickness, right? So just 2 pixels will be enough, right? Okay, let's see. And just image equals to, it will draw the rectangle, it will store in image variable, right? Okay, now we will print it here, we will show this image. I will got just one rectangle, right? So just run this code. After executing this code, I will get images here. We will get images here, right? Okay, so let's see. Just wait, it will take a bit of time. Here, there is one error. Okay. Okay, error says error is going to generate, or just it's going to generate error. Okay, so let's see what error we are going to face. This line is going to generate the error. Okay, so what I'm doing right now, I'm going to firstly close this just one time, and let me check what error we are facing, right? So I'm going to just run this code again. Maybe sometime it happen, you will face the error, right? So there's no doubt about it. It's again going to generate the error. Okay. Okay, it's done. I close this. It's generated the same error, and there's no change, like we not applied any changes, right? Okay. Fine. Camera is not going to this. Okay, mistake is actually what we are doing here. What is our mistake? We are running our code from here. Okay, that was just my mistake, right? Okay, just run this in program Python 3 open cam.py, right? It will open two different faces. It will open two different faces, right? Actually, my PyCharm is not supporting to open the camera, right? But other platforms like my terminal is going to support to open my camera and all these things, right? Okay, so now let's play with this. So I'm going to quit it. I'm going to quit this. It's done. After that, what I'm doing here, I'm going to just firstly remove this. Okay. Okay. After that, what I'm doing here, I'm going to just back my code. I'm going to run same code. After executing the same code, let's see what we will get. Can you see this? One box we are getting. When we box we are getting, we not like we don't know that what is the face. Like if I move my face here, right, then we will get that. Okay, fine. We have this box here, right? But what I want, box will not take place, or my face will not like we will not take place inside the box, right? Box will take the place in front of my face, right? In front of my face, right? That's the main concept, right? And we want to learn this concept, right? Then how we can make the box in front of my face or on my face, right? Okay, so let's play with this. I'm going to close this, it's done, right? Okay. Okay. Now, what I'm doing here, we have x, comma, y, comma, w, comma, h. If we get any possibility, and with the help of this possibility, if we if we are able to find the coordinates of our real faces, x, comma, y, comma, w, comma, h, if we just find these four values, we can make rectangle. So next step is we are going to detect our face. Right? So how we can detect? Let's see. Okay. So what we are doing here, we are going to use this har cascade file. Right? This har cascade file is a really very important file, right? They like these files are decided or just developed by OpenCV community, right? Or CV2 library, inside the CV2 library, right? And we want detect my face, right? So how we will detect it? Firstly, we will use it. We will use this library, or you can say use this trained model you can say har cascade file, right? In this file we have data about different possibilities of faces, right? Different faces, right? Okay, so we will use it. We will train, or just we will pass our image inside this data, inside this har cascade file, and just wait for the response or wait for the answer. That and this file will give you the answer about the faces, and faces will be like coordinates x, y, w, and h. We will get these four coordinates. So let's play with this, how we can find it. So I'm going to just copy this file. I'm going to copy because I have to pass the path, right? Okay. After that, here we will change. And what we will change, we are going to use face class, right? Okay. And what we are doing, cv2 dot cascade classifier. Inside this cascade classifier, we will pass this file name, right? Or this file, complete file, har cascade file, right? So we will load this file in our data, in our face class, right? After that, we have to do nothing. Just we have to pass this gray image, in this class. Just one step we have to perform, right? We have to pass this gray image in this classifier. This classifier will give you the output, an output about your coordinates, x coordinate, y coordinate, w, and h. You will get these four values, right? So how we can do this? Simple, right? What we will do, after converting your image gray, now what my classifier know, or what my classifier want, actually my classifier wants about the gray image, right? My classifier not going to classify your color image, it will classify your gray image only, right? So now what I'm going to do, I'm going to just create a variable faces equals to face class dot detect multi-scale. Detect multi-scale is a function. Right? And this function is inside your face class, right? So here we will pass three values, right? And these three values is just about gray image, about your gray image. First, you will pass your gray image. Second two values, just first value is 1.3 and second value is a 5, right? And what are these 1.3 and 5 values? Let me explain. Firstly, this 5. What happen actually inside this classifier, whenever you will, like this is my detected image, I don't want to open this, there is a, just you can say one window, right? And window is going to start rotating from here, from this pixel, right? And what this window will do actually exactly, this window will rotate from this pixel and complete all the pixels. But firstly it will rotate from here, after that it will reverse and it will rotate from here, right? After it will again reverse rotate from here, right? This window, like how this window is going to create, this window is going to create by our code, right? By our code cascade classifier. So when you run this code, run this command, detect multi-scale, window will start rotating or window will start sliding, right? So when window will slide, what my window will do, every window is going to check the face that in this window we have any face, in this window we have any face, or in this window we have any face, right? So if my window will get the face, then it will return yes. If my window will not get any face, it will return no, right? So what we are applying here, if my window is going to rotate in front of my face, then I am passing about the number of nearest face. It means, suppose what I'm going to explain you, actually what I want to try to say. If my window is rotating here and if my window is here, so my first face is going to match second window because it's going to cover all the pixels, all the pixels. So this is my second window, third window, this is my third window, right? And in every window we are getting face, every window we are getting face. But if my window is here, if my window is here like this at this place, or if my window is here at this place, we will not get any face. But if we have this, and if this is my first window, this is my first window, and I'm getting my face. After next pixel, in next pixel, when my window will rotate, in next pixel, we are going to get the face. In again next pixel, we are getting face. In again next pixel, we are getting again a one face. In next pixel, we are getting a really face, right? In pixels wise, right? So what I'm trying to say to my machine, I'm trying to say to my machine that if we get minimum 5 faces, if we get minimum 5 nearest faces, not like this, that one face is here, one face is here, and one face is here, not like this. 5 continuously faces, if we get, it means there is face. If it means there is face, otherwise not, right? So what we are passing here, 5 means I need at least 5 different face had to match, right? Or not different face, or just one face, but my 5 times window should verify that we have one face here, right? And like this is my window, this is my window, right? And it's going to slide, right? So we want this. So that's why we are passing 5. 1.3 is just my scalar value. I want number, I want to convert my numbers in scalar limit, right? This is just a different concept, right? Okay. So when this will done, what happen actually, this command face class will detect multi-scale. What this command will do, this will give you the location of your face, x comma y comma w comma h. But this will not give you the location in variable. This will give you the location in form of array, in form of array. So if we want to play with array, if we want to play with array, then how we can? For face, not face, we will say x comma y comma w comma h in faces, in faces. So if we have multiple faces, we will get these values. I'm going to delete this, I'm going to delete this, and I'm going to run this line inside this code, inside this command. So what happened, if we have multiple faces will be on your image, right? So what's happening here actually exactly, this function will give you the location of your face. And when this function will give you the location of your face, right, we will grab it and we will save it in 4 different variables, x comma y comma w comma h in faces, right? And if we have these 2 faces or 3 faces, right, many faces we can, right, and my machine can detect multiple faces, right, it will make the rectangle, So I'm going to run this code. If I execute this code, then let's see what happened. Can you see this? On color image, we are going to make just one rectangle. If I move my face, my rectangle will move. If I move my face, my rectangle is going to move. It means my face or my machine can detect my face. If I move my face, my rectangle is going to move, right? It's not asking me that, no, you have to move your face, I'm here, right? What I'm saying, I'm moving, you have to move, right? My rectangle have to move according to my face. So this is my face detection. My machine, my camera can detect my face. If we have multiple faces, my machine can detect. Let me check. I have just one image. Let me check because I don't have any image like in my mobile, because I'm trying to like show you that if we have multiple images, then how my machine will detect these faces, right? So let's see. Okay, let me check. Maybe my machine. Can you see this? My machine is going to detect my face and my mobile camera face on. You can see both faces are getting, or both faces are getting like boxes, right? If I move my mobile, my box will move. If I move my camera, my box will move. My box will move, right? As you can see here, right? Okay, so this is all about the face detection, not face matching or not face verification. I'm not saying face verification. I'm saying face detection. So if we have multiple faces, if we have hundreds of faces, my machine can detect. My machine can detect. So that's a really interesting concept we are learning, right? And now you know that how you can make your own face detection system, right? So detection, right? I'm not saying the matching, right? So don't just confuse that I'm saying the matching. It's just going to detect your face. It's not going to match your face, right? Or verifying your face that okay, it's Pratik. My machine is not saying to me. It says that okay, there is a person, or there is a person, there is a face only we have, right? Okay, so let's play with this. I'm going to quit this. I'm going to quit this. So it's done. It's closed, right? And after that, we are going to make face detection system. That was your just yeah, face detection. We done our face detection. Next we are going to make a face verification system, how my machine can verify my face. It's a really interesting concept we are going to learn. You will definitely enjoy this concept, right? Okay, so we will use same content, but now I'm going to create a new file. I'm going to create a new file, new python file, new python file, you can see, right? I'm going to face verify, face verify, right? Verify code. I'm going to create a new file, face verify, right? Okay, some basic code we will copy from here. Some basic code we will copy from here, like cascade classifier, while true, and faces, and all these things, right? So I'm going to copy this content, just basic content we have. I'm going to contain it, so it will not take too much of time to create it again and again, right? Okay, now what we are going to do actually exactly, this complete project is going to divide in three sections. Three sections we are going to divide our project, right? Okay, first section is store your faces. Store your faces. Second section is train your machine. With your faces. Third section is verify your face. Three possibilities we have, right? And the complete project is divided in three sections. Right? So we will create three different files or three different functions. In each function we will play with this, or we will like apply different possibilities. So first section we will store our data, we will store our faces. Second section we will train our machine with my faces, right, with stored faces. And in third section we will verify our faces. It's really going to interesting, right? And you will definitely enjoy this concept. So I'm going to just cut this from here. I'm going to paste on top. Import CV2 and these libraries is common. After that, the remaining part, we will define a three different functions. We will define the three different functions. So first function is define create dataset. First function is I'm going to define create dataset, right? In Python, how we can define? Just def and use it. So create dataset, right? So what this function will do, this will capture your face, this image, or this function will capture your image and store in your data, store in your folder, or store in your location where you want to store, right? So create dataset. Firstly, I'm going to store my face in my device. Second, I will train my machine. Third, I will predict with my face, or I will verify my face, right? Okay, so let's play with this. It's really going to interest. So now I'm going to create a one folder, new directory, you can say datasets. datasets. Folder name will be datasets. So whatever I will store, whatever I will just capture the image, I will store in this variable, right? So my faces, my images is going to store in this variable, right? Okay, so let's play with this. So what I'm doing here, I will just detect my face. I will just, you can say detect my face. After detecting my face, I will crop my face first. I will crop my face and store in particular location, right? So what I'm doing here, here I have faces. I will get multiple faces. After getting or after capturing multiple faces, what I'm doing here, I will crop this face, right? I will crop this face, right? So how we can crop this face? Let's see. So what I'm doing here, color face equals to color face CV2, or you can say just color face. And what I will do, I will crop it first. Right? So how we can crop it? My original image in my image variable. Original image is in my image variable, right? So firstly, I will crop it. So I will crop image. Same image is my numbers. Image is not just my image. So I'm going to just crop it, or any tool, right? What data we have in this image variable? We have numbers, or we have array. If we want to slice it, we know how many rows and how many columns we want, right? So how many rows we want, how many columns we want. So x to x colon, x to x colon h, right? Or by to by colon h, sorry, right? So we will start from by colon by plus h, we'll get number of rows, right? So where we have this by, okay, so we have this, we have to apply for loop also, right? Okay, so for loop is will be here for x comma by comma w comma h in faces. Here now color face will be, because I'm going to crop my image, and image is my color. Gray is my gray image, right? But I'm going to crop from color, right? So x colon by plus h, it will be my rows, how many rows I want, and how many columns I want, x colon x plus w. So this is my color image, right? Now I want to resize this image. So I want to just make a square image of my face, will be my square face, right? Okay, so what I'm doing here, I'm going to just use color face, same variable. It doesn't matter that what you are going to use. cv2 dot cv2 dot resize, and what will resize my color face. What will the rows and column? How many rows? How many columns? So 200 rows and 200 columns I want. So this is my color face. After that, we will convert it in gray face. So gray face equals to, how we can convert in gray face? We all know cv2 dot this concept. Just use this. So just copy here, paste here. Here you will pass just my color face and nothing. This will convert your gray face, and we will store this in my dataset variable. So how we can store in dataset variable? Simple. How we can store in dataset variable? cv2 dot imwrite. We have an imwrite function. We have to pass the path. So path will be datasets slash image dot, right? But problem is here that if we are going to store 100 images of my face, but if we decide this name image.jpg, suppose image.jpg, and I'm going to store gray face, it will store on my data set. There is no issue, there is no doubt, but only one image we will store. Reason is because every time your image name is same, your file name is same, so every time your previous image will remove, new image will store with the same name, right? So you are trying to store 100 images, but it will store only one image in your data, right? And whenever you will apply the unlock system in your mobile cameras and anywhere, right? So what the system will do, the system will just capture your multiple images. The system will capture your multiple images, right? Okay. So how we can store these images? Let's see. If we apply a dynamic data. So how we can apply the dynamic data? I'm going to use dot and curly braces. Curly braces just give you the condition to enter any number, right? So how we can enter any number? Dot format. Inside this format, you can pass any number. If you pass any number like 123, then image will save like this: image.123.jpg, image.123.jpg, right? So, but again, it's same. So what we can do, we are going to decide just one variable samples. How many images I'm going to save? So samples equals to 0. Samples equals to just 1. Suppose sample equals to 1. So what we will pass? We will pass sample here. After writing this, I will increase my sample just by 1. Right? Samples. How many samples we are going to store? So we are going to store many samples, but every time it will store. It will like you can say it will increase by 1. It will increase by 1. Multiple phases. If we have one phase, increase by 1. If we have two phases, it increase by 2. Right? So what I want after completing this loop, when we will break this loop, if sample SAM greater than 50, if my number of samples will be greater than 50, it means I captured my 50 images. We will break my loop. Right? So my loop will break. And when my loop will break, what we will say? We will say data set created. Simple, right? It's awesome. Data set created. After that, what I want, after the phase, we will show this face, right? I want to show this face also, right? Right? So how we can show this face? Just nothing. cv2 dot imso my face is my title, and what we will show? We will show my gray face. Because I'm going to store this. So what I'm going to show for the user, right? Gray face. So every time when new picture will capture by my machine, every time I will show this face, gray face, right? And sample is greater than 50. If my number of samples, whatever I'm going to store in this dataset variable, will be greater than 50, my loop will break and I will get the answer dataset created, right? Okay, so what I'm doing here, I'm going to call this function. Out of the function and execute this code. So just clear this, execute this. And here you will got the point that my machine is going to start capturing my face. So it's not going to capture. Okay, actually, but just by mistake, I run a different program, right? It's not just open cam, it's face verify, right? It's face verify. So I have to open face verify.py. When it will run this code, right? Let's see. It's done. It's trained your machine, right? If you open your data set, you will get multiple images. It was really fast, right? 50 images we have. Even 51 images to be there. 50 images, definitely. From 1 to 50 images we have, because we are applying the condition greater than 50. If my number of images greater than 50, then it will break. So you can see this. I stored this, my machine stored this face, and in every image we have this face. In every image, my machine is capturing this face, right? And this is just about me, not about me, actually my face. I'm going to train my machine with my face, right? So what we did, we completed first step. First step is store your faces. It's done for us, right? It's not a big deal, right? We created it and we can just perform it, right? So it's simple and easy thing. So data set created. Next step is we have to train our machine. Right? So next step we are going to start train our machine. But before training the machine, if you have any doubt regarding these questions and anyone write anything, you can give me the answer. Just ask me. If anyone have any question, any doubt, you can ask me. I'm just waiting for your response. Like, is it interesting? All of you are getting the points that what I'm trying to teach you or not? Yes, it will verify the faces from every angle, but predefined conditions, because her cascade file are just predefined conditions they have, right? So they will verify with certain limit to certain condition, right? Not all conditions. That's why it's not a part of deep learning. It's a part of this machine learning part, right? Okay. Okay. So let's start. Next step is we are going to just train our machine. So next function is define train machine. Train machine, right? So define train machine. After the training the machine, define train machine. So in train machine we will like do something, some basic concepts, right? What we will do, we will read my image first. We will read my image, just our database, right? And step by step, after reading the image, after reading this, right, we will just convert our images in the form of numbers, and after that we will train our machine, right? So let's see the magic, that how it's possible and how we will do this, right? Okay, let's play with this. So I need, so again, library we have CV2. I need just one library, OS library, OS. From OS import list directory. List directory function will just give you the possibility to read your data. Give the possibility to read your data, right? Okay. And path, path of my directory. So path is my data sets. Path is my data sets slash, where we stored our all the images in data sets folder. So I'm going to just define my path where I have my images, right? So data sets in the folder, right? All images equals to just a list directory of my path. When you do this, what happen? You have these images 1 to 50 images, right? Image 1 to 50 images you have, right? So what happen actually exactly, it will just copy all the file names from from your data set folder to your all images variable, right? If you try to print all images, right? And if I call this function, here, right? And if I execute this function right now, I will get, they're random, like all images we have, but they are not just arranged in a alphabetically manner, right? They are just random images, right? But we have all the images. So whenever we will just a list of directory, whenever we will apply a list of directory, we will get all the images, in this variable all images folder. What next I want? So next will be, after getting it, we will do nothing, just we will apply the for loop. Right? Okay. For I in all images, we will read one by one image. And store in our variable. So what we are going to do here, we are going to create a data frame. We are going to create just not data frame, I can say. We are going to create two variables. In one variable, you will store your image. In second variable, you will store your number, your image number. 1, 2, 3, 4, 5, 6, 7, 8, 13. We have these numbers, right? So in one image, you will store your image data. In second image, second variable, you will store your image number, right? So how we can do this? Let's see. So what I'm doing here, I'm going to just use train data, comma, num. Num is like my image number, right? So I'm going to create a two different array, right? To just blank and a different array, right? Okay, so I have these arrays, right? After this, what we will do, after this, So for I in all images, and what we will do, we are going to open my image. So how we'll open my image? img path equals to what we will use, we will join these two values, right? So we have path plus I. So what happens actually exactly in path, you have data sets, and in I variable you have this image. So your complete data will be like, your complete data look like this. If I print it, if I print img path, and if I execute this code again, I will get this data like this. Just wait. Yeah, we have this. So you are getting this data sets slash image, data sets slash image 30, data sets slash image 24, and all. So all images will be there. All images will be there, right? It's really interesting concept. We are going to like we implement it, right? So we have complete path. What we will do next, right? We are going to convert these images. Firstly, we will open these images first with the help of imread. After that, we will convert these images in NumPy array and store it in train data. So let's see how we can. Okay, so we have this image part. Now, what we will do actually, we are going to convert this. Firstly, we are going to open this image. So I am going to open this img equals to cv2 dot cv2.imread. In this cv2.imread, what we will do, we will pass our image path. So image path we have, and we will apply the condition. We will apply the condition cv2.imread and imread in gray scale. Whenever we will apply it, what happen? Your image will read, or just your image will open from the location and store in variable image in the form of gray scale. Okay, so we have this image. After that, what I am doing here, I'm going to convert this image in NumPy array. So n array, ARRAY, n array, right? So NumPy array equals to what we will do, np. We import it? No, we not import it. We have to import. So import NumPy as np. Import NumPy as np. So we have this. So what we are doing here, np dot as array. We are going to convert my image in the form of array. So np dot as array. After that, we will do nothing. We will just pass my image. And after that, d type is for data type, which type of data I want to store, right? And I want to convert my data in I want to convert the data from this image variable in the form of string, in the form of integer, in the form of float, right? So in the form of string, in integer. So what we'll use, d type equals to np dot uint uint of it, right? So unsigned int, right? U stand for unsigned, right? So uint 8. So np dot 8 is stand for just 8 bit of data, right? So nd array we have. Next, what we will do, we will store it in train data. So how we can store? Train data dot append an array. Append function, what append function will do actually? This is my list, a Python function, a Python data type, right? And if I want to add any data end of the list, end of the location of this list, we will use append. So we are going to append this data. After that, what about number? What about my number, right? So how we can find the number, right? So what I'm doing here, I'm going to apply n equals to 1 by default, just n equals to 1 by default. And every iteration means every loop, we will increase my number by 1, by 1. So I'm going to increase my number by 1, n equals to n plus 1. And now what we will do, we will store this number also. We will store this number also. Where we will store this number? We will store this number in labels, or in, you can say, num variable. We will store this number, right? Okay. So now num dot append, and what we will append? Num dot append, we will append our n, and every time it will increase. So first time it will 1, second time it will 2, third time it will 3, fourth time it will 4, 15th time it will be 50, 50. So when this loop will complete, what we will do, we'll do this nothing. We will convert our data, convert our num in the form of array also, right? So how we'll convert? Num equals to do nothing, the same, np dot as array, and as array will be my number. So these numbers are just number, a list, but I'm going to convert in the form of array. So as array, and what we are passing inside this, we are passing a data type. So just copy this after the number, we will copy here, and after that we will not use uint, we will use int only, int 32 bit, right? There's no, like not compulsory that you have to apply 32 only, right? You can apply 8 and 16 also, right? Okay, I'm going to use 32. So that's done. We have this data. Next step is just one step ahead. We have to train our machine, right? So how we can train our machine? So we will train our machine, like we are going to create a brain of my machine. What we are doing here, actually try to understand, we are training our machine, and with the help of these images, that okay, these images are Pratik's images, right? So all images, inside this all images variable, whatever we have, the complete images of like related to Pratik's face, right? So if you learn about it, if a brain learn about it, that okay, the face related to this structure will be a Pratik's face. It will be for all time. Right? Okay. So what we are doing here, brain. We have this brain. I'm going to create this brain, and after creating this brain, how we can train our machine? So cv2 dot face lbph, local binary face histogram. Local lbph is just an algorithm, right? It's a really very deep and very important algorithm we have, right? But right now I'm not going to explain a complete algorithm, but we have this create. So what we are doing here, we are applying this algorithm lbph, local binary face histogram, face recognizer algorithm we are going to use. So just we will use a create. So it will create your algorithm. In next line, what we will do, we will just use train, brain dot train, right? So train, train. And what data we will pass to train our machine? We will train with train data. Simple. We have this train data and we have these numbers. So we will use it. Train data, comma, number. It's done. After training your machine, what we will do? We will just print it. Print will be my brain has trained. My brain has trained. That's great, right? So this is all about training your faces, training your machine with different faces, right? So we have only just one person of face. So I'm training my machine. With these faces. That's done, right? And it's really interesting concept we have. So when you execute this command, when you execute this function completely, your machine will learn, right? Okay, so just as I'm going to train, I'm going to execute, face verify. You can see this. My brain has trained, right? So this is about training your brain, that how we can train our brain, right? Okay. Next, what we are going to learn, we are going to predict, we are going to classify my face. So how we can classify? Simple, easiest thing we have, right? Whatever we learn, right? The classifying the image or just detecting your face is easiest possibility we have, right? You will definitely enjoy this concept, right? So just wait and let me start, right? Okay. Okay, so after training your brain, what we have to store my trained brain. As you learned one time, as you know that CV2 library is useful to play with images or to detect my faces, right? We all know about it, right? Same thing, we know about it, and it's for all time. You're not going to forget it. That CV2 is not going to use for images. CV2 is going to for just going to use for games. It will not happen anytime, right? Why? Because you learned about this concept, and you have this concept in your brain, and you saved it inside your brain memory, right? Inside your brain memory. Same thing we are going to do here. After creating my brain, what we will do, we will store my brain. We will store my brain, right? So how will store my brain? Do nothing. Just use brain dot save. Brain dot save. So we have this brain. I'm going to save this brain. So trained trained brain. This is my trained brain, right? And trained brain dot by ml in the form of by ml. I'm going to store this model and store this brain in the form of by ml. After storing this, what we will do, we will just print. And in this print, what we will pass your brain is saved. Good news we saved our brain, right? So all the times we don't have to train our machine. That we will train our machine, then we will after training my machine, we will again like you can say predict my face. It's not like this. You trained your machine one time, you captured your faces one time, all times you can decide, you can detect your face. It's not compulsory, right? Okay, so let's play with this. Sorry, not here, right? Not here. We will execute this here. Face verify. Can you see this? My brain has trained, your brain is saved also. My brain has trained, your brain is saved, right? And where it's saved here. Can you see this? Trained brain.byml file. We have one file, right? And we created right now, right? It was not like before this execution, right? It's here, trained brain. And what we have in this trained brain, you can't imagine that what we have. But we have this data. We have this data in my trained brain about my images, about my algorithms, about my content, and a lot of things we have in this file, right? So I'm not going to read it also, right? It's done. I'm going to comment it. I'm going to comment it. 2 steps. We completed our 2 steps. We are going to jump on 3rd step and easiest step we have, right? Easiest step, right? So this called define, verify, or you can say function name is face verify. Face verify. We are going to verify our face. We trained our face. Now let me verify my face that it's like a known person or unknown person, right? Okay. So how we can verify? It's easiest possibility we have. What we are doing here, we are going to firstly open my brain, as you know. And now in any time, if any friend will ask you that just give me the answer that what is the use of CV2. So what you will do, firstly you will connect to your brain, your ears are going to connect to your brain. Inside your brain memory, you are trying to find that what is the answer we have, and your brain will give you the instant answer that okay, CV2 is just useful to train our faces or to detect our faces, or just image processing library we have, or CV2, right? So what you are doing here, when you got this question, this question is going to connect to your brain, and brain will load it. Brain will load, or your memory will load in your brain, right? Whatever you stored in your memory, in your past memory, in your previous memory, you are going to load it in your brain. And after that you will predict, that okay, I loaded my previous memory, right? And now I am going to predict it, that okay, the use and you will get a correct prediction, right? So what you will give the answer, you will give the answer that image classification or image processing library we have, right? Same thing we have to do here. We trained our machine, we trained our brain, we stored our brain in past memory, in previous memory. Now here we are going to call it again. So how we can call? Brain equals to just do nothing, cv2 dot face lbph recognizer, right? Underscore create. Yeah, or you can say sorry, dot create. After opening your brain, you have to read. You open your brain door, right? You have to read your memory. So how we can read? Brain dot read. And in this read, you will pass your file name. So my file name is trainedbrain.byml. You will use this, right? So whenever you will read it, after that you have to do nothing. Your brain knows about you. Knows about you. Next step will be nothing. Just open your camera and check that you are entering correct face or not, right? So you have to predict it only and nothing, right? Okay. So let's see how it works, right? So just I want to execute this code first, right? So we'll get just one answer that we are getting any error or not, right? Okay. So if I execute this code, I'm going to just clear this window and execute this code. It's done. There is no error. It means your brain is like going to open your mind or your memory and going to read your memory. Now what we have to do, we have to just use it. So how we can use? Maximum possibilities are same. We are detecting our face, color face, gray face. Till this step, everything will be same. Step. Open your camera to till end. I'm going to paste it. Everything is same. The sample number is not useful. So you will open your camera, read your face, convert your gray scale, detect your face. Inside the faces, whatever face you will get, you will just crop your face, resize your face, convert your gray scale of your face. So you have this gray face, right? So till gray face, you don't have to change anything. You have to apply same thing. Just 3 lines of coding, your face will be in front of you. It means your machine will able to detect your face directly. It will not ask you that I have to detect or not. Your machine can detect your face, that it's a known face, it's an unknown face. Simplest thing we have, right? These steps are easiest, right? And we know about these steps, so we don't have to think about it, right? But next is we have to predict. So only one line we will call, only one line we will use, right? And do this, right? So what we will do, just out is just variable output, and output of my brain, and what we will do, predict, and predict will be my gray face. We will pass gray face, right? Gray face inside this out function, right? Okay. And if I print out, right? Then what happened after Getting this, we get two values. We get two values. What two values we are getting? Okay, try to understand. I'm going to open my Excel. So with the help of this Excel, I can explain you easily. Okay. So what you did actually, you trained your machine with images, like image. Here you have different 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 image, and here you have different image. You trained your machine with images, and these are the numbers. These are the numbers. These numbers are different. Suppose these are numbers are different. So when you call this line, predict, then what will be the output? So output contains two values. Output contains two values. If I give you the overview of output, it will give you like this: output and value 1, comma value 2. Value 1, comma value 2. Right? Okay. So what we will get in value 1? In value 1, you will get the number of image. You will get the number of image. Like I trained our machine with 50 faces. How many faces I'm going to train? With 50 faces, I'm going to train. So in these 50 faces, what I want that V1 and V1 comma V2 we have, right? So what I want in value 1, we have number of my face, like which face I'm going to like verify. So my image is going to verify that, okay, your face is going to match with third number of face. So first value will be 3. What about second value? Second value, you will get just a number, and a number can be just from 1 or 2 or 3 to 500. 1 or 2 or 3 to 500 number can be exist, right? Okay, so what you will get a number, and this number is reverse. And what this number will say, that what is the possibility that your face is not going to match. Your face is not going to match. Not just match. You're not going to match your face. You are asking that my face is not matching or matching. So my machine will give the number that your face is not matching, and matching with this number. So if my number is less, my face is going to match accurately. If my number is high, my face is not going to match, right? So this number will be your not face. This number says that this is not face. Not face means not predicted face or not correct face. This number says not corrected face. So if we have less number or less not correct face, right, we will get good prediction. If we get high number, high not face number, then it means my face is not going to predict, right? So we have two things, right? Okay. So what we are doing here, inside the out, we will apply one condition. If out of 1 less than 40, 40, right? Less than 40. Like if less than this, it means my face is going to match correctly, right? Because 40 is that your face not match. 40 is your face not match, and 60 is your face match. Like suppose, like if your range is 1 to 100, then 40 face not match, 60 face match, right? So I'm going to apply this. So if out 1 less than 40, it means your face is going to match. So what we will do, nothing, the CV2 dot rectangle. CV2 dot rectangle, and rectangle will be on my image. Location of my image. So location of my image will be same. X comma by and x plus w comma by plus h. So x comma by, after that in next parenthesis x plus w comma by plus h. After that color, if match perfectly, then green color. If not match, red color, right? Okay, so green color will be like, you can say BGR, right? So 0 to 55 0. Thickness of your color. Right? Okay, so thickness of your color will be like, you can say 2 pixel, 3 pixel, just by mistake 3, so it's 3, right? Okay, but if it will not match, we will do nothing. We will just copy this line, just change the color, and BGR, blue, green, and red, right? Okay, so what we are doing here, we are applying like this, BGR, red color, right? So it's done, right? After creating the face, after creating your rectangle, do nothing, just CV2 dot IMSO. My face will be my title, and image will be my data. After that, we will apply the condition, and condition will be again same. If CV2 dot bit key of 1 equals to 13, Then we will break our loop. And after breaking the loop, what we will do? cv2 dot destroy all windows. Simple. Problem solved. After that, I missed just one concept. After destroying your windows, you have to close your camera also. You have to close your camera also. So camera you are going to open here. So you have to close this. Otherwise, it will open infinite time. So cam dot release, cam dot release will stop your camera. It's done, and it's your complete project, right? Okay, let's see. I'm going to clear this command. I'm going to execute this code. Yeah, and let's see what you are getting. My camera is opening, and now, as you can see, my image can detect that my face is going to match. Sometimes it will not match. If I move fastly, it will just generate the red box, right? It's going to generate the red box. Otherwise, it's going to match, right? There's a really important concept we have, right? And we can detect our faces, right? So my face is detecting. Now, if I want to print also that, hi Pratik, right? Just I welcome you, that we can detect our face also, right? So how we can make it, how we can detect our face, let's see. So I'm going to close it, click enter, it's closed, right? Okay, I'm going to close this cell also. It's not important, so I'm going to just minimize this, right? After that, what I'm doing here, you can see numbers. I'm printing it. Sometime you will get numbers greater than 40, 43, 43, right? So it will not detect, it will be red, otherwise green. Here you are getting the green, that's why your number is less than 40, and every time less than 40, right? That's why you are getting correct prediction. Sometimes you are getting 50 also, 53, 56 sometimes, right? So this is these are your numbers, right? Your data, what you are getting in the outputs. You trained your machine with 50 images, so these images, this number or your number of image, and nothing, right? Okay, clear, finish. This is your face detection. If I want to print something, if I want to print, or if I want to just draw the text, then how we can make it? cv2 dot put text. I want to put a text, right? And put text on my image. So this is my image where I want to put text on my image. After that, where I will put, right? So we have what we want to insert, a Pratik. Like this is my text. I want to insert it on my image. So hey Pratik, right? After that, okay. So I'm writing hi Pratik, like okay, just because of some reason I was busy, right? There was a call, right? So that's why I just stopped. So right now continue. So we have cv2 dot put text image, then hi Pratik, right? What I want to insert here, what I want to insert on my image, right? So I want to insert hey Pratik, right? Okay. After that, you have to apply, you have to pass the location of your x coordinate and y coordinate, right? Okay. So like suppose my x coordinate will be 250, 250. I mean, what we can do actually, I want to find my x coordinate and y coordinate, right? So x coordinate will be same. X coordinate will be same of my box because I want to print this hey Pratik on box, on top of my box, right? So when my face will move, hey Pratik will move, right? It's really amazing, right? An interesting concept, right? So I'm going to pass the coordinate where I want to write. So starting will be x, and by coordinate will be y minus 20. By minus 20, you will got the point. Not right now when I execute this code, right? Okay. So x comma by minus 20. We have this concept, right? Okay. It's really interesting concept here. So we applied it, right? So it's not a predefined command because what happens if you pass a predefined location, if you move your face, your hey Pratik will not move. And if it will not move, it will overlap on your box. It will overlap on your face, right? We don't want it. It's not an intelligent possibility, right? It's not a good possibility. We have to make an intelligent system, right? So if we use x comma by minus 20, it will be coordinates according to your face coordinate. So sometimes what happens if you train your machine with two different faces, if you want to write a two different name on different boxes, you will get a two different name. That was the main concept we have, right? Okay. So x comma by dash 20, by minus 20, not dash, sorry, right? By minus 20 we have. This is the location. After that, what we will do, we will use cv2 dot font. Yeah, simple. First, simple, right? I'm going to use simplex key, right? Or simplex we will use, or I'm planning to use complex. This one, complex, right? It's just a font family, right? You can use multiple font possibilities we have, right? After that, what we will apply font width or font size, like, okay, or font height, you can say 1. I'm going to pass 1. After that, color of my font. So definitely I'm using a green color. So I will pass green here, 0,255,2. After that, what we will pass? Okay, there's the 2 parentheses. We don't have to apply. It's 1 parenthesis is enough, right? But we are passing 2 parentheses. 2, thickness of your bird, thickness of your text, right? Okay, now let's see the magic. I'm going to execute this code. After executing this code, run this code, right? Like this, and you will get the answer. Can you see this? Interesting. Like if my face will not match, it will hide. Hey Pratik is not going to print, it will hide. But if my face will match, you can see, hey Pratik. And it's moving, just I'm moving. So hey Pratik is not fixed. What happen if you learn from any place, right? What happen actually, point, they will like explain you about the fixed point, fixed possibility, right? That you can write your thing, right? But here I'm writing on a just, you can say flexible mode. So if you move your face, your hey Pratik will move according to this. You can see this. I'm moving my face, my hey Pratik is going to move. Right? So that is like our basic face detection. If I move my face, like there is a distance also. If you have a distance on your face, but your machine can detect your face, right? So this is the complete project or complete concept of detecting of your face. As you can see here, your machine can detect your face. If we have multiple face, my machine can detect multiple faces. Just you have to train your machine with multiple faces and nothing, right? So I hope you are enjoying this class. Right? And definitely it will be profitable for you. You can make that type of project directly, right? So what I want, it's just 1 o'clock right now, and what will be our next project? Next project is going to really interesting project. We are going to learn. You will definitely enjoy our upcoming next project, right? So I'm going to close it. I'm going to close this. It's done. What we are going to next, we are going to make object detection project, right? So how we can detect our project? Let's see. This is like, I have this car, dog and car image. I have this image, right? After detecting my object, my machine will detect the objects and it will give you the answer like this. We have this dog, we have this car, and the dog says 99% accuracy that this is the dog, it's confirmed, and this is the car, it's confirmed. We have this also, dog and cat. So my machine will detect also, right? It's not possible in the real world, right? Dog and cat will sit like this, right? But we will detect it. Dog and cat we have, right? And dog and car we have. So we are going to make this project, upcoming project, or next project we are going to start, right? Okay. So I want just your feedback first. After that, we will decide that what we have to do, right? So I want just your feedback, just basic feedback that are you enjoying this class, right? And are you thinking that it will be really helpful for you? And just waiting for your answer. Like if you give me the answer, then it will be good for me and good for all also. If you are enjoying this class and if you are thinking that it's really helpful, so you can give me the answer that yes, it's profitable. Then we will just think about next concept. Okay, fine. Like I think it's really profitable, right? And you all are give me the response, right? It is profitable. So what we are doing now, right? And what will be our next step? We are going to take for break, for lunch break, for 30 minutes, just only for 30 minutes break, right? After 30 minutes, we will start this project. How we can make this project? It's really interesting. You can make this project, and after this project, you can submit as a project also. Because rarest person know about it, that how we can make it, right? So just take for break, 30 minutes break. After that, we are going to make this, right? So I'm waiting at sharp 1:30. At sharp 1:30, we will start our class. So if you want to make this, and so you can join, right? I was just one thing. So take a break, and we will get back soon, or we will start. Okay, fine. Bye bye. Next session will be 2:30 or 2:30 or 3 o'clock, max to max 3 o'clock. Next session will be till 3 o'clock. At 3 o'clock, we will finish. It just depends on this project, right? How much time it will take, right? This project will take, if take a maximum time, then it will change, right? Okay. So next session, we are going to start.